Yeah, let's do 9. 9 is a hard one. So for the log, basically Euclid never test very fancy log function, just the basic log. So usually we should be using a basic log function, right? There's no basic log function is what? So log a. So basic log function is log a b, where you go to log a plus log b, right? Something like that. Also log a b, where you go to b log a, right? This is big B log a. And sometimes also fancy is log a and b will be equal to change to another one, right? Log b log a. Yeah, this is base. It can be any base. Okay, so like, so this is a basic log function. So he never tests a fancy log. Eventually, he will go to the original simple equation, right? For this one, yeah. First of all, we're gonna extend this one, right? We copy here. Yes, cannot copy here. Cannot. Okay. So let's go. Yeah, C log x log y, right? Minus 3 log 5. Minus 3 log 5. 5y. What is that? Right? Is that right? Yeah. Okay. So here, so we gotta using this the old one to try, right? So this 5y equal to will be log 5. Yeah, log y, right? The same thing. Okay, now we started that equation. Say this one and this one and this one is constant, right? Only this two is not constant, but we here we say this is log y, this is log x, this is log y, this is the same thing. So we go back here, log yz, and zx, xz. So we kind of understand that he want us to do. So basically he want us to factorization, right? So for factorization, so we say here, we try, basically we can guessing this is factorization, we should like this. So y, for y is 3, x is 1, so we should give the 3 to here, and the log y minus 1, right? So this log yx cover this one, and a 3y cover this one, and a 1x cover this one. We're missing 3. 3 not covered. 3 not covered. We should give the 3. So a plus 3 here. 3 cover here, right? This time this cover here. Now we cover everything. Now we have all the constants here. So basically this is 3 log 5 plus log a. Yeah. This is special thing, right? This is special thing. If you merge them together, the 3 power come back here. This is 5 3, right? 5 3 is 125. 125 times a is 1000. 1000 this one turn to 3, so eventually this is will be a plus 6. Now we try the second one. Second one, this one should be show up. If we do this process, we can show up, right? Y must be negative minus 1, x minus 3. Then you can do the substituting the parameter, right? So let's do the second one. Second one will be log, change it to the color, say log what? Log y, log z, and minus 4, 4 log, right? 4 log of 5 minus 4 log of y, yeah, minus log 16 minus log z, right? This one we do factorization, log y master minus 1. Is that minus 1? If not minus 1, this solution, we gotta think about another solution, right? Minus 1 should be okay, yeah. And then log z will be minus 4, right? Equal to b plus. So log y log z cover here. This is 1z, 1z cover here, right? 4y covered here. So basically we're missing 4. Should we put 4 back here? And we'll plus 4 log of 5 plus log 16, right? This one 4 log of 5 go back 16 is what, right? So this 4 log of 5 is this is 2 log of 5. Eventually this is 5 power 4, this is 2 power 4. Actually it's 10 power 4. So this coming back here, it will be 4. So basically this one will be b plus 8. Right? So we get this one, so it's good. So here and here is good. Now we need a final to prove that this is right. So the final one is log z log x, right? And the minus will be 4 log a, 4 log a minus 4 log x, right? 4 log x minus 3 log 625 minus 3 log z, right? Here we have like log x minus 3 must be 3, right? So log of z minus 4. We see it cover or not, right? This one covered. This time this is covered. 3z cover here, right? 4x cover here. Now we left here 12 not covered, should be plus 12. Then we merge this back 4 log a, 4 log a, and plus 3 log 6 to 5. Log 6 to 5 is what? This is 125 times 5. This is how much? This is 12, right? This is 125. This is 5.412. This is 12, right? And 12. This is what? This is 2 power 3 times this one, also 12. So eventually this one should be 12, right? 12. So total eventually C answer should be C plus 24, something like that. Now we know this. Now we know what's going on here. This, let's use the red one. Now we use this one, y, this here, right? And log z is here. So we can eventually changing this one to get the answer, right? So for the first question is simple, right? You put the number in, you find this one is 2 if you change this one to x, y, z and add this one, right? And this practice, so they put a here, this is going to be 2, and put a b here, this is going to be 12, and put a c here will be 6, and put together will be 12 square, and this you put it like changing this one, you can change this one to ABC, or just directly using that one. So basically this times this will be 3 parameter power will be like 12, right? So when you root back, oh, you can still mention that root back. When you root back, don't throw away the negative one, so it's kind of like plus minus 12, right? So every answer will be like this, will be like, see, if you use minus 12, the answer will be minus 6 and minus 1 and a minus 2, right? The another answer will be like, if you use positive 12, it will be 6, 1 and 2, right? So let's say for one of them, let's say for example negative 6. Negative 6 is the total, is the ABC divided by this one should be C. It's not here, log Z. So log Z, so for example log Z minus 4 equal to negative 6, right? So one by one, solve the one by one, negative 6, also the positive 6. Then log Z will be negative 2, Z will be 10, negative 2, like this. This is one of them, right? And so far we got the Z, and we do the same thing. This one should be easy, right? So one by one we get just this. For this A question, we just don't forget it to get the second answer. So plus, see, this should be like highlight here. This is 12 here. 2, okay, you 2 answers. So this answer have 2 set. So the answer have 2 set. X, Y, like X, Y, Z have 2 answers. Okay, 2 answers. Yeah, one of them I show you here is here, right? So now we're looking for determining. Yeah, have like infinite, right? What's have infinite? So how can we have infinite, right? So this is all irrelevant, right? So we just generic talking will be like changing this one to A times B equal to something. Let's equal to X. It's okay. B times C will equal to Y. C times A will equal to Z. Right? So the answer will be solved. This one will be A square B square C square equal to X times Y times Z. Generically like this. ABC will be equal to whatever, plus minus root X Y Z, right? So basically like this. Okay, and so he asked for generic solution. No, not generic. Sorry, infinite. The key is find infinite solution. So we can say we can case study, right? So first the case study is like if X, Y, Z less than 0, if less than 0 is no answer, so it should be no solution. No solution, right? This is the first thing. No answer, no solution, right? If X, Y, Z greater than 0, this one have 2 answers. Then divide by each one, like the A, what we did here. A, this have 2 answers. 2 solutions, have 2 solutions, right? Now only left us chance is this X x times y times z is 0. Is 0. Let's have chance, right? So now we have this start from here, right? Now we study again. If one of them is 0, let's say x is 0, y, z is not 0, right? X is 0, y, z is not 0. Okay, this one you can warlock, right? You can warlock because this is symmetry. Doesn't matter x 0. We just pick up one of them. You can use yeah, the fancy word warlock. I like this warlock. Without lose what did I say? Generate what did I say? It's called without lose of generate whatever. So if x equal to 0, then a and b, one of them must be equal to 0. If a and b, one of them must be equal to 0, then y of z must be one of them must be equal to 0. This against that one. So it cannot. So it definitely cannot, right? So now we have say if x equals to 0, y equal to 0. No, y equal to 0, right? Y equal to 0. Y equal to 0. And z cannot be 0, right? That case exists. So x equal to 0, y equal to 0, right? So so that chance is possible or not, right? We can looking for that. In this case, what happened? In this case, because z is not 0, so this one cannot be 0. C or A cannot be 0. That put B should be 0. So this one concludes that is possible. B will be equal to 0, right? B equal to 0, then B equal to 0. That's possible. So, right? So if B equal to 0, C and A can be anything. So this is infinite, right? We just say put a B is 0 and a C and A could be anything. See here. B is 0, B is 0. These two both are 0. And C and A, it could be anything, right? Could be anything. That one is the answer, right? So y equal to what? Let's say y equal to what? B plus C equal to B plus A, yeah. So B is 0. So we say x and y. XY, we come back. XY actually represent what? XY actually represent this is x and this is the y. What do we say? Okay. So then we say A is -6, C is -24. So we say A is -6, C is -24, right? This was Z, doesn't matter. It doesn't matter anything. Z, yeah. So it doesn't matter, right? So we can have infinite answer. So the triplet we'll find here is infinite will be what? -6, B, -24, right? So for this one symmetry, this one we have like x, y equal to 0. We do another 2 combination. We'll find another one. Should be -6, -8. -8, right? Should be -8. This one equal to 0 should be -8 and C, right? And the other one, this is A, -24. So this one, if we have this answer, This answer, if we set this ABC, if have infinity answer, right? Infinity. Yeah, here we almost done, right? We almost done. But we notice this here. We notice this one. We notice B here, C here. We notice that case. What about this one? We gotta notice that case, right? This case, make x equal to 0, y equal to 0 equal to 0. If this one only have one solution, so we need when we write the answer, we need to say, oh, this is 1, this is 1, this is 1, and exclude that one, right? And we exclude, because if this one have one answer, like you gotta exclude them. It's like so many set, general set here. This is one set, two set, three set, right? The three set have one node sitting here, right? One node sitting here. And if this one is have one answer, not infinity answer, we need to include it. So just be very careful. Maybe was 1 point, right? So because the tester think you got this answer, but you didn't think about this only one set. This one, right? This one have both. One have one set. So this is our third case: x equal to 0, y equal to 0, z equal to 0, right? For this case, what happened? Then we study here, for this case, what will happen is this both equal to 0, then one of them, this like, if we pick A and C, let's say x, y, z is 0. Let's say, for example, x equal to 0, y equal to 0, z equal to 0, right? Then we can pick A, because equal to 0, right? So basically we can pick anything, like with this one, pick A is 0, C is 0. If we pick A, is C 0, right? And that one works, right? B doesn't matter. So the B doesn't matter. So this one, in this case, is valid, right? So how to prove that? When we say, okay, we random pick A is 0, C is 0. If we put this 2 is 0, B can be anything, right? B can be anything. Then we have x, y, z. We have lots of like solution here. Yeah, let's repeat again. So if we have this 2, if we set this to 0, 3 of them to 0, right? If this 3 is all of them equal to 0, it's same as this before, same as this 2 is 0. So we can pick up 2 is 0, and any 2 of 0, and the rest B can be anything. So this is also infinity level. So we confirm this one is valid, so it's okay. So this 3 set, and include this one, like should include this one. That one is the final one. So conclusions, this question is hard, right? This is hard. First one is very, very hard, right? But for the log things, you gotta believe that log, he never tests fancy log functions. There's no log. Log only working for the, in the beginning, we say log only working for the basic operating. So he must test something else. So this one is text, like when we using the basic log. When we use the basic log, we just like turn here, from here to here, like 5y turn to 5 plus y, and ax plus a plus x. So when we do this one, now we have ideas. So this is test your factorization. So you can factorization, and you find out this is both 3 factorization, right? He just set up the question, and the answer is here, right? So this is the first part. Second part is prove infinite. Prove infinite is just very be careful. So infinite will be very careful. This step by step should be okay.